Ramon, please do me a favor.
What happened, Traxie?
My mind goes blank and I can't think of any creative idea for my final assignment. It's about researching two scientists that have remarkable attributions for the development of quantum theory and mechanics, I chose William Francis Jock and Wolfgang Pauli, but I can't find any information like any useful and interesting information about them on the internet.
Okay, follow me and I'll show you some beneficial data about them.
Okay, let me tell you some basic information about Mr. Jock. Did you know Niagara Falls in Canada?
Yes.
That's right. This Mr. Jock fatherland, and he was born on May 12, 1895, and he died on Berkeley, California on March 28, 1985. Although he was born in Canada, his nationality was American, and he graduated from University of California, Berkeley, and the fundamental subject of his study was low temperature phenomenon. And throughout the career of Mr. Jock, he received a lot of awards for his attribution, especially Nobel Prize for Chemistry in 1949. Okay, so let's move on the research that Mr. Jock conducted. The first experiment was about the low temperature research on the third law of thermodynamics supervised by Mr. Gibson. That was his professor when he was in the university. Another experience was about the relative entropies of glycerines, crystals, and glasses. And from this research, Mr. Jock proved that the third law of thermodynamics was a natural law, that it is unsuitable for all kinds of distorted systems like glasses. Besides, Mr. Jock, along with his students, also conducted a study that calculated accurately thermodynamic quantities, especially the absolute entropy of condensed gases at low temperatures from spectroscopic data. Jock also determined accurate thermodynamic properties of samples like entropies by comparing the quantum statistic. In addition, throughout the study of extreme low temperature, Jock identified that there was the existence of other oxygen isotopes 17 and 18 when he noticed oxygen can absorb additional neutron. This also indicated the difference in the atomic weight values for the oxygen used by chemists and physicists. Another investigation attributed to the development of modern science was about the innovation of the diabatic demagnetization method of using magnetism to obtain temperatures below 1 Kelvin, while he was investigating the relationship of thermodynamics with the magnetism. After a host of attempts, Jock was able to reach the crystal's temperatures of 0.004 Kelvin. Do you know what is the significance of Jock studies? Okay, let me tell you about this. Jock studies broadened a horizon in examining the properties of matter, as well as predicting what would happen with the elements at low temperatures. And also, when Jock found out that oxygen can absorb additional neutron, it was attributed to the recreation of a new periodic table with the altered weight. And besides, the research of Mr. Jock had a profound impact on producing material for industrial commerce. For example, we can, with the effect of low temperature, we can produce a stronger steel and also an advanced glasses and etc. And about the interesting part of Mr. Jock, when he was in the university, he saw kind of goody two shoes that he rejected all the temptation of the life. Because he wanted to lighten up the financial budget for her mother. He rejected all the temptation, like he was never seen to consume alcoholic beverages or read fiction, and he just once in a while did outdoor activities like playing football or basketball, etc. Okay, so let's move on to the second scientist that you chose, Gufang Polly. As I googled on the internet, Gufang Polly was born on April 25th, 1900, and he's dead on December 15, 1958, and his nationality was Austrian. And also, the domain that he studied was subatomic particles, neutrino, Pauli exclusion principle, and the most important, quantum number. And throughout his career, Pauli received a lot of awards and honors, especially Nobel Prize for the physics. Nobita, did you notice that we changed the background?
Yes.
Yes, I changed the background to give you more motivation to our lesson. Okay, so let's continue. Throughout the career of Gufang, he also had three fundamental research. That is, in 1925, he had proposed a quantum number for the spin and electron to the two possible values up and down. I know that you learned that in the class, right?
Yes.
Ah, that's right. And then he extended this to formulate the Pauli exclusion principle in 1925, states that two no electrons can exist in the same quantum state. And the last significant research of him is, in 1950, he conjectured the existence of neutron particles, which later come to be known as neutrinos, to resolve the conservation of energy in nuclear beta decay. So, from all of this devotion, we can conclude that Gufang contributed substantially to the modern theory of quantum mechanics and the study of physics of particles at atomic and subatomic level. Okay, finally, the most important part is the hilarious fact about Gufang Pauli's life. Gufang Pauli's life had a great sense of humor that, according to my big memory, he resembles one day he knocked the characteristic of Gufang on the radio, and then Gufang sent him a letter to respond the criticism of Heisenberg's. And in this letter, he wrote that this is to show the grid that you can paint like tissue. Just a few technical details are missing. And in this letter, he drew a rectangle to criticize the criticism of Heisenberg. And also, you know what? Pauli was obsessed with the perfection and he's not allowed himself to make a mistake. And he told his college that I don't mind if you think slowly, but you do object when you publish more quickly than you think. And also from this quote, the term of the Pauli effect was generated. In conclusion, I think that the two scientists contributed a lot to the development of quantum theory and mechanics.